The cryosphere is a term used to describe the frozen parts of our planet, including snow, ice, and permafrost. These frozen regions play a crucial role in regulating our planet's climate and are home to a diverse range of species. But what is the chemistry behind the cryosphere? How do these frozen regions interact with the atmosphere and oceans, and what impact do they have on our planet's climate? In this video, we will explore the chemistry of the cryosphere, starting with the basics of ice formation and the properties of snow and ice. We will also look at the chemical processes that occur within the cryosphere, including the role of ice in the carbon cycle and the impact of melting ice on ocean chemistry. Join us as we delve into the fascinating world of the chemistry of the cryosphere. Snow and ice are formed when water freezes at or below 0 C. But what happens at a molecular level when water freezes? Water molecules are made up of 2 hydrogen atoms and 1 oxygen atom, arranged in a V-shape. When water freezes, these molecules arrange themselves into a crystalline structure. This structure is known as an ice lattice, and it is what gives ice its unique properties. Ice is less dense than liquid water, which is why it floats. This property is important for aquatic life, as it allows them to survive in frozen lakes and rivers. Ice is also a good insulator, which helps to regulate the temperature of the cryosphere. Snow, on the other hand, is made up of individual ice crystals that are loosely packed together. This makes snow a good insulator as well, which is why animals like polar bears and penguins use it to build their dens. Understanding the properties of snow and ice is crucial for understanding the chemistry of the cryosphere. The cryosphere is not just a passive player in the Earth's climate system. It is also an active participant in a number of chemical processes that have a significant impact on our planet. One of these processes is the carbon cycle. Ice sheets and glaciers act as carbon sinks, trapping carbon dioxide from the atmosphere in the form of organic matter. Over time, this organic matter is buried under layers of snow and ice, where it is compressed and eventually turns into a type of sediment known as glacial fly. When glaciers melt, this sediment is carried downstream and into the ocean, where it can have a significant impact on ocean chemistry. Glacial fly contains high levels of iron and other nutrients, which can stimulate the growth of phytoplankton and other marine organisms. This, in turn, can have a positive impact on the ocean's ability to absorb carbon dioxide from the atmosphere. However, the melting of glaciers and ice sheets can also have negative consequences for ocean chemistry. As glaciers melt, they release large amounts of fresh water into the ocean, which can disrupt ocean currents and alter the salinity of seawater. This can have a significant impact on marine ecosystems, including the distribution of fish and other species. Understanding these chemical processes is crucial for predicting the future of the cryosphere and its impact on our planet's climate. The cryosphere is particularly vulnerable to the effects of climate change. Rising temperatures are causing glaciers and ice sheets to melt at an alarming rate, with significant consequences for our planet. One of the most visible impacts of melting ice is the loss of habitat for polar bears and other Arctic species. But the melting of ice also has significant implications for our planet's climate system. Ice reflects sunlight back into space, which helps to regulate the Earth's temperature. As ice melts, more sunlight is absorbed by the Earth's surface, leading to further warming. Melting ice also contributes to sea level rise, which can have devastating consequences for coastal communities around the world. In addition, the melting of permafrost in the Arctic is releasing large amounts of methane, a potent greenhouse gas, into the atmosphere. This feedback loop, where melting ice leads to further warming, is one of the most concerning aspects of climate change. It is up to all of us to take action to reduce our carbon footprint and protect the cryosphere for future generations. The cryosphere is a vital part of our planet's climate system, regulating temperature and playing a crucial role in the carbon cycle. But the cryosphere is also one of the most vulnerable parts of our planet, with rising temperatures causing glaciers and ice sheets to melt at an alarming rate. Understanding the chemistry of the cryosphere is crucial for predicting the future of our planet's climate and taking action to protect it. We all have a role to play in protecting the cryosphere, from reducing our carbon footprint to supporting policies that promote sustainability. By working together, we can ensure that the cryosphere remains a vital part of our planet's ecosystem for generations to come. Thank you for joining us on this journey into the fascinating world of the chemistry of the cryosphere.